and start with chapter 5. So what we're going to be looking at is Law of Sines. And to begin with Law of Sines, you need to realize that we're talking about triangles again. We're going back to triangle trigonometry. But the first thing you want to know is what we mean by an oblique triangle. So an oblique triangle is just any triangle that does not have a right angle in it. Okay, so an example of this would be a triangle something like this, where you had say a 100-degree angle, maybe a 40-degree angle, and that would force that to also be a 40-degree angle. That's not drawn to scale, obviously. So, but you get the point. It'd probably look better if I changed a couple of these angles right there. All right, so anyway, you have any kind of a triangle that no right angle anywhere to be found in it. So, say 70, 60, see those would add up to 130, so that would force that to be a 50-degree angle. So that's a little bit better triangle. All right, so what we want to look at as we're going through some of these problems then is you want to get clear as to all the different types of cases that we have when we're dealing with triangles in. So I'm going to just basically draw some kind of have you draw just some sort of a general triangle on each one of these things, and we're going to look at what these things represent. So if I said you have an angle side angle, what that means is I give you an angle, and I'm going to start here and just say that's like 35 degrees, and then you're going to have a side. So let's say that side is 10 inches, and then we have another angle and say that's 100 degrees like that. So if you're going clockwise around this triangle, you would have an angle, then a side, then an angle like that. So you can either kind of go around the triangle clockwise or counterclockwise. So you have an angle, then a side, then an angle. That's called the angle side angle case. All right. And then let's say you have a triangle that looks like this. And the angle side case would mean, well, I give you an angle. Let's say that's 65 degrees. And then I give you another angle, say that this is 32 degrees. Then I give you a side, say that this is 15 feet. So if we were going clockwise around this triangle, what I've given you is a angle, then another angle, then a side like that. So it's called the angle side case, right? Another possibility is you could have something kind of like this, okay, where you have a side, then an angle. So let's just say that we know this side is 15 inches. Okay, then we know this side maybe is 10 inches. And then we know this angle is maybe 111 degrees. Okay, if we went clockwise around the triangle, we'd have a side, then an angle. So that one's called the side angle case, all right? One thing I always kind of laugh about is I never see a trigonometry textbook ever call it the ASS case, although I kind of refer to it a lot that way. And I teach it that way because students seem like they remember it better. So if you want to consider that to be the ASS case, then you can definitely do that if you want to. All right, so the next thing we have is a side angle side case. And this goes like this. So I'm just going to draw some kind of a triangle like this. And the idea would be I give you a side. I'll just start with a side and say that is 2.5 centimeters. Then I've got an angle, say that this angle is 52 degrees. And then I've got another side, say that this is also 2.5 centimeters. So again, if we go in clockwise or counterclockwise around the triangle, what we have is a side, then an angle, then another side like that. So it's called the side angle side case. All right, then the last thing we're going to look at would be if you knew all of the sides. So for instance, if you knew this was 7 centimeters, this was 7 centimeters, and maybe this was 10 centimeters, that would be known as the side case. So one of the things you want to be pretty comfortable with is that you know what each of these cases mean and are able to identify those then. Okay, the next thing we're going to look at, and I'm not really going to do a derivation of this, is called the Law of Sines. And the Law of Sines is defined to just be ratios around a triangle. And this works for any triangle I want to stress. It could be a right triangle or an oblique triangle, and it always works. So it's basically you just take the sine of an angle and divide it by the opposite side, and you can form those ratios all the way around a triangle. So what I want to do on this is I want to use a triangle that we are already familiar with. Okay, let's look at one of our special triangles that we already learned about. Now let's see what we come up with on this. This is not really going to be a proof, but it's going to be a demonstration of how this works. So let's go back to the 30, 60 right triangle. And the way this works is we learned that the sides can be reduced down to these proportions. We could have a 1 opposite 30, a square root of 3 opposite 60, and a 2 like this. Now I'm going to demonstrate this on the calculator first. Then I'm going to do a little bit more specific work analytically. So when you do the law of sines, this is basically what you do. You pick an angle, and we want to make sure our calculator is in degree mode as we're doing this. So I'm going to go to degree mode. And what I do is I do the sine of that angle. Then I divide that by, the opposite side, which is 1. And that'll give me a ratio of 0.5. Okay, then I go to another angle and match up its opposite side. So on the calculator, I could say sine of 60 degrees and then divide that by the length of the opposite side, and it gives exactly the same thing, see? And then finally, I could do the right angle and do that. So I can do the sine of the 90 degree angle divided by its opposite side, which is 2, and I get the same thing. So what you would do on that is your calculator can be used with the law of sines to verify that all the angles and sides are correct, because every triangle that there is satisfies the condition of law of sines. So you can use this as a way to check and verify an answer to any triangle problem that you ever solve. Okay. Now what I'm going to go through next here is we're going to look at an example of the angle side angle case and then the angle side case like this. So we're going to solve the triangle. So first of all, in this particular problem, notice that I gave an angle, then a side, then an angle. So it's the angle side angle case. So we're going to find the remaining parts of this triangle. So we obviously need to find gamma, alpha, or side A and side B. So those are the 3 parts that we need to find. The logical place to start on this problem would be finding angle gamma, because we know that all of the angles in any triangle are going to add up to 180. So I already know the other 2 angles, so I could just add those 2 together like this. So I would get gamma is equal to 180, and then if I add 51 and 26, I get 77 degrees. And then I could subtract that. You can use a calculator if you need to. So if we got 180 minus 77, that's going to give 103 degrees. All right. So what we've done is we've got our angle filled in. Okay, so what I'm going to do on this, just kind of as I get these pieces, I'm going to put these in. So that's 103 degrees like that then. All right, now what we have to do is we have to use the law of sines. So in order to use the law of sines, at a very minimum, you always have to know an angle and an opposite side. And we do know that now, see? All right, so what I'm going to do is just kind of go through. I'm going to erase some of these little keystrokes that I did there. I want to keep that 103 in there. So the idea on law of sines is you have to match an angle with an opposite side. All right. Then you have to have another angle and then an opposite side. So I'm going to start by finding side A in this. So the 4 things that I highlighted are going to be, we're going to be able to write a proportion. Okay, so what I'm going to do is we're going to go ahead and get our proportion set up. Now the way I do this is I always put the unknown in the upper left-hand corner. You don't have to do that. You can set this proportion up however you want to. But if you choose to put A there, then you have no choice but to put the sine of the opposite angle. And since I'm making the decision to put the sides on top, then I got to put the next side I know, which is 26. Then I put that over the sine of 103 degrees like that. All right, now that's the law of sines. You have a side over the sine of the opposite angle is equal to another side over the sine of its opposite angle. Now, you solve the equation and you use your calculator. So I'm going to multiply both sides by the sine of 26. And by doing that, then I'm ready to go to my calculator. Because see, now what I have is I have A is equal to precisely 26 sine of 26 degrees over sine of 103. Then I'm just going to go to the calculator and approximate that then. Okay, so I'm going to do in degree mode. I want to make sure your calculator's in degree mode. So we're going to do 26. Then the sine of 26 degrees, you want to be sure you close that parenthesis. That's real important. And then divide by the sine of 103. And then we'll round this off to one decimal. So let's say that is 11.7. Okay, so I'm going to fill that in, and then I'll put that in my triangle as another part that we found. We found that's 11.7. Okay. All right. Now we got one more part to find. Now you cannot use the Pythagorean theorem. Okay, this is not a right triangle. Remember the Pythagorean theorem, a squared plus b squared equals c squared. That's only going to go along with right triangles, so you can't do it. So you have to basically do the law of sines again. So let's set up our proportion. All right, the next unknown I have is b, so I'm going to put b. I'm going to put that over, and I'm going to erase, these little things I highlighted here, because I want to kind of show you what I'm doing here and what my thought process is. I need to match that with that and that with that. Now, you could also match a with 26. I always try to tell students to use as much of what you were given in the problem as possible. So I'm going to go b over sine 51. Okay, like that. Okay, now take another side that 26, and put that over the sine of the opposite angle. All right, so this would be a law of sines proportion that we can solve. So we're going to multiply both sides of this equation by the sine of 51 degrees. All right, so that's going to give b precisely is equal to 26 sine of 51 degrees all over the sine of 103 degrees. Then I'm going to go to my calculator and approximate, rounding this probably to one decimal. So 26 times the sine of 51 degrees. Close that parenthesis. If you don't, it's going to screw up. And then divide by sine of 103, like that. And then you got your answer that we can round off is about 20.7. All right, so it looks like we're all completely solved. One thing I like to kind of do and try to get students to do on these problems is see if your answers make any sense to you. Okay, one thing that I see on here is the biggest angle, 103, has the biggest opposite side. The smallest angle, 26, has the smallest side. So that's logical, but then what you want to do to verify this is you want to just do law of sine. So watch how I do this. I'm going to pick a side. I'm going to start with 26, and I'm going to divide that by the sine of the opposite angle, and I'm going to get the answer. Then I'm going to move around the triangle. Let's go to another side. Let's go to 11.7. Let's divide that by the sine of the opposite angle and see if we get the same. And we do. Then take your other side, 20.7, and divide that by the sine of 51. And we get about the same thing. I'm off a little bit on that one. That kind of makes me a little suspicious that maybe I did a bad calculation on there or something. I'm going to try that one more time when I got B. But it could just be the rounding error, so I do want to just crunch that in one more time. So I had B over sine 51 equals 26 over sine 103. So I should have put in 26 sine 51 degrees, and then divided that by sine of 103. And if I'm off a little bit, it's okay, but that would probably be just due to rounding errors. So that's about right, okay? All right, so that would be your first example of a law of sines problem. And again, they're checkable and verifiable if you're doing homework or if you're doing a quiz or a test, it's worth your time because it takes less than a minute to take your calculator and check and see if you're right like I just did. So you should do it. Okay, now the next thing we want to look at is, as I proceed through the next thing, is we want to go down to the second case. Over again. Okay, so now we're going to go to the next case. This time I did not draw a triangle. I don't have to draw a triangle, certainly. So I would recommend that you start this problem by just sketching a triangle. It doesn't really have to be drawn to scale or anything, but it's kind of helpful to visually see what's going on in the problem. So let's go ahead and start by sketching a triangle of some sort. Label what we're given and then kind of label what we need to find. Okay, you can label the angles however you want to, but the sides have to be consistent with the angles. So I'm going to start by naming this. I'm going to name this gamma, and I'm going to name this beta, and this alpha, and that'll force this to be A, B, and C like that. So you got to do your naming convention. Now I'm going to put in what I gave. So I gave beta is 48.7 degrees. I gave gamma is 111.1 degrees. And then I also gave side B as 21.45. So if you look at this, you're going to see that I gave you an angle, then an angle, then a side. So I've got angle, angle, side if I'm going around that triangle counterclockwise. Right? So this is enough to use law of sines. And the thing that I want to stress over and over again on this is the reason I know I can use law of sines is because I have an angle and a side opposite. Once you have that and one other part of the triangle, then you can use law of sines to find the rest. Okay? So the logical place to start on this problem again is I've given you two angles, so we might as well just go ahead and find angle alpha. So we're just going to add those two angles I gave you, 48.7, and we're going to add those together and subtract that from 180 degrees. And you can do this in one step on your calculator if you want to. So I'm going to take 48.7 plus the 111.1, and that's going to give 159.8. And then I can subtract that the sum of those two angles from 180 to get the leftover angle. So that's going to be 20.2 degrees. So I'm going to go ahead and type that in as an answer. All right. And I'm going to kind of, in red as I'm doing these problems, I'm going to go to my triangle and just sort of fill things in as I have them. Okay, now it's time to use law of sines. So what we're going to do is we're going to match up. We now know we can either find A or C. It's up to us which way we do. Let's go ahead and start with C and match it up with its opposite side. All right, so what I'm going to do on law of sines, again, is I make a proportion up. I generally always put my unknown out of these four things in the upper right-hand corner. So I'm going to say C over the sine of the opposite angle is equal to side B, 21.45, over the sine of 48.7 degrees, and then I've got a proportion I can solve. So what I'm going to do is multiply both sides by the sine of 111.1 degrees on both sides, like this. All right, and what I'm going to have now is I've got C is equal to 21.45 times the sine of 111.1 degrees all over the sine of 48.7 degrees, like that. Okay. Now I go to the calculator. So we're going to go 21.45 times the sine of 111.1 degrees. Got to close that parenthesis. Divide by sine of 48.7. And then we'll round that off to, say, 1 decimal. So we're going to have, that's approximately equal to 26.6. Okay, then I'll fill that in. So side C we now have as 26.6 units, whatever that is. All right, now that leaves me with one more thing. That leaves me now with finding A. Okay, so I'm going to make one more proportion, one more law of sines proportion, and finish up the problem. Again, no Pythagorean theorem. This is clearly not a right triangle, so the Pythagorean theorem does not hold. So I'm going to set up my proportion. This time what I want to find is A. So I'm going to put that in the upper left-hand corner. So I'm going to put A over the sine of the opposite angle. Okay, like that. And then I'm going to pick a side. I'm generally going to go with what I was given. So I was given this and this. So I'm going to do this side, 21.45, over the sine of its opposite angle. Then I can solve that proportion. So I'm going to multiply both sides by sine 20.2. Okay, like this. And then I'm going to go to my calculator. So I've got A is equal to 21.45 times the sine of 20.2 degrees, all divided by the sine of 48.7 degrees. Okay. Go to my calculator, and then we'll have this filled out. So 21.45 sine 20.2 divide by sine 48.7. Okay, round that off to one decimal place. So we'll have A is about 9.9. All right, and then that should finish up the problem. Okay, now let's go ahead and just very quickly check and verify that we're right. So pay attention to how I do this. Let's start with side A. Do 9.9 divided by the sine of the side of the opposite angle, 20.2. Get the answer. Okay, pick another side, say B. 21.45 divide by sine of opposite angle, which is 48.7. Should get the same thing, or close. And then the last side is C, 26.6, divide by the sine of its opposite angle, 111.1. And notice you get about the same answer, off a little bit because of rounding, and that's all. If you round to 2 decimals, 3 decimals, and so forth, you're going to gain some accuracy. Okay, so that's how law of sines works on the angle side case and the angle side angle case. So I'm going to go ahead and let you guys go up to number 3. I'm going to pause this a little bit, give you a little time to try to work this problem. Okay, so let's see how we did here. First thing we're going to do with this one is, again, I've given a angle side case is what this one is. And the reason we're going to be able to use the law of sines is because ultimately we have a side and then we have the opposite angle like this. Okay, so we got this and we have that. So we have enough to use the law of sines on. So I'm going to start on this just by doing the, let's see, we got this angle. I'm going to make sure I got everything labeled on this. Okay, I guess I didn't label this very good. So I'm going to call this one's going to be gamma because that's opposite C. This is going to be angle alpha. Then this is going to be side A. So now I've got everything I need. Now, I think I obviously did this wrong on here. So this is supposed to be, we need to find angle beta, it looks like. Okay, so let's get that corrected first of all. So let's start by finding angle beta. Angle beta would be 180 degrees minus what the other two angles are. We had 11.2 plus 131.6. So we're going to go ahead. I'm just going to do that on one step in the calculator, which you can always do. So I'm going to do 180 minus parentheses, if you want to do it this way, 11.2 plus 131.6. And that'll be about 37.2. Okay, so we got that solved, and I'm going to kind of do what I've been doing. It's just piece things in, kind of put things in red as we go along this then. All right, now we're going to do law of sines, so we need to kind of decide where we're going to start. I'm going to match these things up. I'm going to match this with this, and I'm going to match this side with that angle. So let's do it that way. So I'm going to do B, side B, over the sine of the opposite angle, okay, which is 37.2. And then I'm going to do the side 92.4 and divide that by the sine of its opposite angle, 11.2 degrees. Okay, I'm going to multiply both sides by sine of 37.2 degrees, like this, and then get the calculator out to get what side B calculates to, and I'm going to round that to 1 decimal. So let's do 92.4 times the sine of 37.2, okay, close parentheses, divide by the sine of 11.2, and that will give a pretty big side. So that's 287.6. So let's put in the answer to B is 287.6. So now we've got two answers, just got one more to go. So I'm going to put in side B in red is 287.6 just so we can check. Okay. Then I want to do law of sines one more time. So I want to set up my proportion here. And that leaves me with C, so I need to do side C over the sine of the opposite angle, which is 131.6. Match up side A, or you can do B, it doesn't matter. I'm going to do A, which is 92.4, divided by the sine of its opposite angle. And again, I try to use what's given in the problem. And then I'm going to multiply both sides by the sine of 131.6. And then I'll go to my calculator and just round to 1 decimal then, okay? All right, so let's pull the calculator out. Let's see what we get here then. So let's do 92.4 multiplied by the sine of 131.6, close parentheses, divide by sine of 11.2 degrees, and we'll round that off to 355.7 units. Then that should solve the problem. All right, then just to do this an additional time, I'm going to just make sure that I'm right on this. So I'm going to go like this. I'm going to start with side A, and I'm going to say side A is 92.4. I'm going to divide by the sine of its opposite angle, 11.2. Get that answer. Okay, then I'm going to go to side B, which was 287.6. Divide by the sine of its opposite angle. That gives the same. And then finally side C, 355.7. And divide by the sine of its opposite angle. And then that will verify that that's the right answer. Everything you see pretty well came out the same or close to it. Okay, now let's go to the next thing. And what we look at on this is the famous ambiguous case that we get into. So this would be if you have an angle and a side, or as I like to call this jokingly, the ass case. Okay, it's up to you, whatever you do, so that's why I put the donkey on there then. So basically, here's kind of the idea. This would be an example of an ambiguous case. So I'm going to have you just maybe draw a triangle out, and then we'll kind of look at a couple of basic issues on this. I'm also going to pull up a website here in a minute to go through that's kind of helpful. So let's say, for instance, that you were given an oblique triangle like this, and let's say that you were given that this side was like 32 degrees, and then let's say you were given this side was 10 feet, and you were given this side was maybe 12 feet. Okay, now that's what we consider to be the ambiguous case. You have the ASS, an angle and a side and a side. So if you see an S in your triangle, I always say that sounds funny, then you know something unusual is going to go on. Okay, so if I give you these three pieces here, then there's possibility. So this is kind of a strange case. What happens is, if you're given this ASS case, SSA, ASS, whatever you prefer, it's possible that there's no solution. Sometimes I give you three things and it's impossible to make a triangle. Sometimes it's possible, it's only possible to make one triangle, and then sometimes it's possible to make two triangles. Now I'm going to pause here just for a second. I'm going to pull up a website to kind of show you how this works. All right, so I pulled up this GeoGebra applet. GeoGebra's got lots of great things for helping students understand different situations. This is an example of the ambiguous case. So notice that you've been given an angle A, a side B, and a side A. So it turns out that this is the ambiguous case. This would be a perfect example of something where it's impossible to make a triangle out of it. So if you're given an angle of 29.7, this side and this, notice, see, you cannot change angle C, or actually C could be found to be any value. But notice, even if you changed angle C and made it bigger or smaller, side A would never close and make a triangle. So it wouldn't be possible for that thing to go down, even if you change that and form a triangle out of that. So as side A gets bigger, then, it becomes possible to actually make a triangle out of it. So eventually that is going to be long enough to make a triangle. And then if that side gets too big, then it's possible to make two triangles. So you could actually have this triangle here, and then you could have this whole big triangle right here. So think of the big triangle and the small triangle as two things that you would have. So that's one of the things that happens on this. And if we change that angle, see, sometimes it's going to be possible to not make a triangle. And even if we change this side B, then it might be possible to make a triangle out of it. This would be a one solution case right there. So if you kind of play with this, one of the things you're going to discover on this is this side A is less than the height of the triangle would be. That's the reason why you can't make a triangle out of that. All right, so there's this, if you kind of play around with this website, and you can look at this link right here if you wanted to type that in and play with that, then it'll kind of help you understand all the possibilities that you have there. There's a one solution case there. If I change this angle in different ways, that's a one solution case like that. See, there's a no solution case right there. And then if I change that angle, then you got a one solution case and so forth like that. Okay, here's an example of a two solution case where you have this small triangle and you have the big triangle like that. So that's kind of a nice little applet to help students see that and kind of begin to formalize that. Now what I'm going to do is I'm going to show you these two diagrams that I added here. And you can write this down if you'd like to. I'm going to show you how to solve the ambiguous case. Usually the math kind of leads you to figuring out how many solutions you have on this, and that's what I'm going to show you in a minute here, though. So basically, this is what I wanted to kind of cover and talk about here a little bit. So you have a fixed angle. You have a fixed length, and you have a fixed length. This is the angle, side case. And when you have that, if this side A, here's the height of the triangle, so if this side A is smaller than H, then it's impossible to close a triangle. No matter what this angle up here is, it's impossible to make a triangle out of that. Okay? If A is equal to H, so basically if you brought this down and made that equal to this length there, then you could make one triangle. Okay, so you could do that. And then the other thing that happens on this is if this side A is smaller than H, but at the same time bigger than B, okay, then it's possible that you would get two solutions, okay, where you get some kind of a solution going like this. So if H ends up being smaller than B but bigger than H, just imagine if this length's a little bit bigger than H, then you could have a triangle here. Or you could have a triangle there. You could have this big triangle or that small triangle. So if A is in the middle of the height of the triangle in this, then you're going to get two solutions, okay, like that. And then if A is bigger than B, so if I took this triangle right here, here's side B, which is fixed. If I made side A bigger, like that, well, then I'd have to move that angle up, and I'd make one triangle out of that. So you got to think about that a little bit. Hopefully that'll help you kind of get some idea on that. That takes a little bit of time and a little effort to understand what all that means. What I'm going to go through and show you is just if I give you the ASS case, how you would go about solving it then, okay? So to begin with on this, we're going to start by drawing a triangle and just kind of seeing what we got. So let's go ahead and start by drawing our angle B. That'll be kind of our fixed angle here. So I'm going to go ahead and have you just sort of start by doing this. And let's call this angle right here, let's call this the fixed angle beta. And that's going to be given as 58.3 degrees. Okay, that's set, that can't change. Okay, that would mean that this side right here, this side B, we're going to say that's 4.47. And then side A, I'm going to call this, I've got an angle, then I've got a side, then I've got another side. So I'm going to call this side 22.6, and I'm going to call this potentially the angle alpha and the angle gamma like that. So you have a ASS case like that. All right, and so what you've been given on this is alpha would be opposite the 22, the A is opposite that, and then the side B is opposite beta like that. So this would be like your side C like that. Okay, well, what we want to do on this is, remember, these things are fixed. The three things I gave you can't change. That angle can't change, that side can't change, that side can't change either. Just by looking at that, because that angle B is so small, or that side B is so small, it kind of looks like it might be a no solution case. But what we're going to go ahead and do is we're going to go ahead and just match up and do a law of sine. So what we can do is we can match B with its angle and A with the unknown angle. So this is the way we're going to start the problem, is when we do law of sines, we're going to go like this. We're going to start with what we're trying to find. So we got to do sine of alpha over the length of its opposite side, which is given. And then we're going to go to the angle that we were given, sine of 58.3 degrees, and then we're going to divide that by the opposite side, then we're going to see what happens, okay? So when you solve this proportion, the logical approach would be just to multiply both sides by 22.6. So what you would end up getting then is you would have the sine of alpha on this side, and I'm going to write this as 22.6 times the sine of 58.3 degrees all over 4.47. Okay, then what I'm going to do with this is I'm going to go to the calculator, I'm going to bring down this sine of alpha, then I'm going to calculate this stuff right here. So I'm going to do, get the calculator on, and I'm going to do 22.6 times the sine of 58.3, and I'm going to divide that by 4.47, like that. So I'm going to write down the result of that is 4.30, okay? And you can put as many decimals in here as you want to, it doesn't really matter. Okay, so the idea is if we want to find alpha, we have to do the inverse sine of this quantity. Now, if you're really on top of how these things work, you could tell me what the answer to this is automatically. If you don't, just do your calculator will explain this, really. So if I do the inverse sine of 4.301640061, you're going to get something that's undefined. So it's impossible for this angle to exist. So you are undefined on that because, remember, you can only take an inverse sine of numbers between -1 and 1, okay? That's the domain of an inverse sine, is you can only work with an inverse sine of numbers between -1 and 1. So what this means is it means that this is the no solution case. And what this would mean is if you made the height of the triangle, and you can find the height of the triangle, I'll show you how to do that, it would mean that this thing is less than the height of the triangle like that, okay? Now, the problem's done. That's all you have to do to solve the problem. The no solution case is the easiest, but what you can do is if you want to find the height of the triangle, see what you can do is the sine of 58.3 degrees, by definition, is opposite, which would be the height of the triangle, over the hypotenuse was 22.6. So if I went through and multiplied both sides by 22.6, I would get h equals 22.6. So you could even cross multiply if you wanted to. Like this, let me show you what happens on this. So if I did 22.6 and multiplied that by the sine of 58.3, okay, I end up getting this. Okay, so the height of this triangle is about 19.2. So if you look at this, that height's about 19.2. See, B is smaller than H. That's why it has no solution. Okay, you cannot close that side. Remember, you can't change the length. You can't change BA and the three things you're given. You can change angle alpha. You can rotate that, but it's impossible to make a triangle out of that. So that's ambiguous case number 1. Okay, now here's what happens on case 2. So we're going to go ahead on this one and draw a picture of a triangle on this again. So we're just going to, I gave you an angle alpha, so let's just kind of represent our angle alpha of 30 degrees. Okay, so I'm going to write that as alpha, and then alpha is 30 degrees. So that's going to be something that I gave you. I'm going to kind of put what I gave you in a blue color, like that. Okay, then the side opposite, we're going to call this, this next angle that I gave you is going to be, you have to have an angle, then a side, then a side. So I'm going to go like this. I'm going to take this length out, and I'm going to call this B. I'm going to do this one more time to make this kind of look, so it can kind of show the case that you're going to have. So I'm going to make that like that. That's my 30-degree angle. And then I'm going to call this angle here. I'm going to have that side like this. So we're going to say this is angle alpha. Side A would be opposite that. So I'm going to call this A equals 3.9. Okay, then I'm going to call this side B, which is 7.8. That's going to force that to be gamma, and that's going to force this angle, if it exists, if a triangle exists, to be beta like that. Okay, so again, notice what we have. We've got an angle, then a side and a side, so we do have the ambiguous case. You see the S in the triangle, so you know something unusual is going on. That's what I tell students, okay? All right. Now what we end up doing is we just start solving. Okay, we got to set up our proportion and we see what happens. So what I'm going to do is I'm going to start with B. So I'm going to say sine of beta. I know the side opposite, so I put 7.8. I pick the other angle I know the sine of 30 degrees, and I match that up with its opposite side like that, and then I just solve the equation and see what happens. So I'm going to multiply both sides by 7.8. Then I'll go to my calculator. So what I have is I have the sine of beta is equal to 7.8 times the sine of 30 degrees over 3.9. And what you're kind of looking for, remember, you're going to do the inverse sine, so you want to make sure that this value is between -1 and 1. So I'm going to go ahead and work that out. So I'm going to do 7.8 times the sine of 30 and divide by 3.9, and that'll give me 1. Okay, so we're within the domain where we need to be. Now if I do the inverse sine of 1, that'll give 90 degrees. Okay, so we have basically beta is the inverse sine of 90 degrees. So that does give us a legitimate answer to that problem. Okay, now I think on this problem, I think I gave you alpha, so obviously what I intended to put there was beta. So now what we have is we have beta is 90 degrees. So that means we have at least one triangle solution. And what you're going to find on this, on a unit circle, what you kind of get into this ambiguous case here is there's only one place on the unit circle where this statement's true. Only one place, and that's why we're going to get one triangle. The only place that this happens is at 90 degrees. That's where the sine's 1. There's no other place between 0 and 180. And remember, all three angles of a triangle add up to 180. So we've got that. Now what we got to do is just finish up the solving the problem then by law of sines. Okay, so let's go ahead. We can find the angle, of course. We now know that so this is really a right angle now. So then we could conclude that to find gamma, we just do 180 minus the two angles, which are now 30 and 90, which would be 180 minus 120, so that's equal to 60 degrees. Okay, so we know that we have a 30-60 right triangle, basically, then. Okay, now we could use Pythagorean theorem, since it's a right triangle, and but let's not do that. Let's do law of sines to finish this up then. So let's do a law of sines ratio. The last thing we got to do is find C. So I'm going to do side C. Now let's see, I think I have that. Gamma is 90 degrees is what that is. And then this angle right here is 60. Okay, so we found beta. Beta is 60 degrees. I think I kind of totally got that backwards there. No, I was right. I'm sorry. I got my diagram kind of messed up here. So it goes like this. So I'm just going to kind of redo this so it looks a little bit more accurate here. So basically we just found that we had a 90-degree angle there. We had a 60-degree angle there. Okay, so gamma is 60. The reason I'm confused, I'm used to gamma being 90. Okay. All right, so what I do is I say C, side C over the sine of 60 degrees. It doesn't really matter what we work with. I'm going to work with, let's work with beta and B. So B is 7.8 and angle B is 90, so we're going to say sine of 90. Okay, and really you can do this like this. You can multiply both sides by sine 60 so that isolates the C. So that's going to end up giving me C is equal to 7.8, and then the sine times the sine of 60 all over the sine of 90. And the sine of 90 is 1, really. So then what I can do is I can put this in the calculator. Come on. And get this crunched out. So what I'll have is 7.8. Zoom out on that calculator. So I got 7.8, then I've got times the sine of 60, and then divide that by the sine of 90. So I get the final answer is C is equal to 6.8 approximately then. And then the problem is solved. Okay, and then that could be checked. So there's just one answer to this problem. And the reason we had one answer is all because of this statement. You're always, when you do law of sines with the ambiguous case, you're always going to end up finding an angle to start with. And that angle is either going to have no answer, one answer, or two answers. There are times if you get two answers to that angle, then a second triangle will end up giving you a negative angle, so it will be impossible. Okay? So that's kind of what happens on that situation. We had one answer. So I want to kind of show you what we conclude about one solution. One solution just means there's two possibilities. Either A and H are the same, and that's exactly what happened on this problem, is A and H are the same. So if you actually were doing the problem that we just did, you actually have this situation on your triangle kind of like this. You started off with alpha is 30. We found beta to be the right angle, and we found gamma to be 60 degrees. Well, the height of the triangle is this. So to find the height of the triangle, we'd do sine of 30 equals side opposite, which is H, over the hypotenuse, which was given as 7.8. So H is going to be equal to 7.8 sine 30. So let me show you what that gives. So I've got 30 times, 7.8 times the sine of 30, and that gives 3.9. So H is about 3.9 on that. Notice that's the same as this. Okay, so that's why we got one answer, is because those two things match. This is the same as the height, so therefore we have one triangle answer. Okay, so I'm going to do one that's got two possibilities. Let's go to this number 6. And the way this works basically is like this. We're going to go ahead and start by doing a triangle on this. So let's go ahead and just sketch out some sort of a triangle. So let's get a side. Let's just close in a possible triangle on this one. And do this. This one's going to end up having probably two possible cases, and we'll kind of, as we go through this, I'll explain why I know that. Okay, so let's get everything labeled. Let's say that this is our fixed angle beta, which is 27.5 degrees. Side B was given as 15.25. That's fixed. We're going to call this alpha, and this is going to be side A is 16.51. So make sure that you've got angle, side, side. So that means we need to find gamma, we need to find C, and we need to find alpha. So we've got these leftover parts of the triangle to figure out then. Okay. All right, well, what we do is we start by finding something that we can find. So if you look at this, notice we have an angle and an opposite side. And we can start by finding angle alpha because we know it's opposite side. So I'm going to work with those three things. So I'm going to go ahead and write out a law of sine's proportions. So I'm going to start with angle alpha. So I'm going to say sine of alpha over the length of the opposite side. Then take the angle that I was given. So we're going to do the sine of 27.5 degrees over 15.25 like that. And then we're going to solve this proportion. Okay, so let's multiply both sides by 16.51. And then we'll go to the calculator. So we're going to have sine alpha equals 16.51 sine of 27.5 degrees over 15.25. Okay, so let's go ahead and let's crunch this out on the calculator and see what we get. So 16.51 sine of 27.5. And divide that by 15.25. So remember, if we're going to do an inverse sine, the answer to this calculation's got to be between -1 and 1. So this time it's around 0.5. So let's just go ahead and round this so it's about 0.5, like that. Okay? Now, what happens in this case is this. Now, if you were to go through and if you were going to do the inverse sine of 0.5, there are actually two answers to this problem. So if I do inverse sine of 0.5, my calculator is going to give me a quadrant 1 answer, so it's going to give alpha equals 30. But what you have to understand on this is if you were looking and considering, a unit circle, there are really two things going on this problem. This is really a 30-degree reference angle, but you could also have a 30-degree reference angle there, so you could also get a 150-degree angle. So we would say alpha is 30 or alpha is 150, so we end up generating two triangle answers on this problem then. Okay, so what we end up doing is when we go to our answer blank, well, we're going to have 30 degrees, or we're going to have 150 degrees. So see, we end up getting two possible triangles out of this problem then. So we have to go through and solve and get both answers to this problem. So there are two answers, okay? All right, so let's go ahead and crunch out. Let's finish up this first case. So we're going to start by doing case 1. That's the triangle we already drew. So what we just figured out is we have a 30-degree angle there. So we need to figure out what that angle right there is for gamma, so we can go ahead and do that. All right, so what we're going to do to find gamma is angle gamma, of course, would just be 180 minus what the two other angles add up to. And that should be a possible angle in a triangle. So if we do this, we just do 180 and then subtract off the 30 plus 27.5. And then that gives an answer of 122.5. So gamma is approximately 122.5 degrees. Okay, and then that leaves us to find C, which we can do that by applying the law of sines. Okay, so we've done kind of these parts of the problem. We figured out an angle. We figured out there was two possible answers to that statement, and we got this right here. So what I'm going to do next is I'm going to go ahead and set up a law of proportions, law of sines then. So I've got gamma is 122.5, and that leaves us to find side C. So I'm going to do one more law of sines proportion here. So I'm going to do C over the sine of its opposite angle. So we're going to do the sine of 122.5 equals, and then pick a side and angle you know. Let's go with B since that's what I gave you. So let's go 15.25, that side there, divided by the sine of the opposite angle. Okay, like that. Okay, then I can cross multiply. So you would get C is equal to 15.25 times the sine of 122.5 degrees all over the sine of 27.5. And then that'll give the solution, the first triangle solution to this problem. So let's do that, crunch that out on the calculator. So 15.25 times the sine of 122.5, and then divide that by the sine of 27.5. So I'm going to get about 27.9. So C is about 27.9. Then that'll finish up the problem for us then. Okay, so that would be 27.9. So now I've got all my parts. So I've got C and its angle, I've got alpha in its side, and I got beta in its side. So you could go through and do a real quick checkaroo on this if you wanted to, which I always like to do. So I'm going to do 16.51 side A divided by the sine of its opposite angle. That, and I'm going to do side B, which is 15.25. Divide that by the sine of its angle, which is 27.5. So you get the same thing. And then finally the last thing is side C, which is 27.9 divided by the sine of 122.5. So that means that that is a valid answer to the problem. So we've now got our first answer to our problem. Now we just got to find the second. Okay, so now I'm going to go down and I'm going to start over again with a new triangle. Okay, so that's what I recommend, is just draw a new triangle. This time it's going to be more of a oblique triangle with an obtuse angle in it. So I'm just going to go ahead and draw this out and just really start over again. Okay, so I'm going to go back to what we had. So in the diagram, to begin with, what we had was, we said this was beta, we said this was alpha, and this was gamma. So go back to what you were given in the problem. You were given beta was 27.5. That's fixed. You were given side A was 16.51. And then you were given side B was 15.25. Well, what we found is, we found that when we were doing the sine of alpha as 0.5, we found that it could either be 30 or 150. So what we want to do now is work with alpha being 150, then we can finish up the problem then, okay? So what we need to find, in other words, is we just need to find alpha and we need to find side C. So if we can find that and that, then the problem is solved. Okay, so what I'm going to do is angle gamma is going to be 180 minus 150 plus 27.5. Now what will happen on this is, if we got a negative angle, then it would be a bad triangle. So every now and then you go on to solving the second triangle, but it can't exist because of a negative angle. So it takes you back to one triangle. So the math will kind of lead you through which case it is. So this is 150 plus 27.5. Want to make sure we get a positive answer, and we do. So 2.5 is a valid angle. So now we just got to do law of sines to finish up then. So let's do our law of sines proportion. So we've got C over the sine of the opposite angle. Pick a side. Let's go with, say, 15.25 over the sine of its opposite angle. And then we can solve this by law of sines, and then we'll have the problem solved. A lot of work when you have two triangle answers. All right. So let's go ahead and just do this on the calculator. So we're going to have C is equal to 15.25 times the sine of 2.5 degrees all over the sine of 27.5 degrees. And then that'll finish up the solution then. Okay. So 15.25 times sine of 2.5 and divide by the sine of 27.5. So it's going to be about 1.44, and then that would solve the problem. Okay, so you've got basically the remaining parts of solution 2 are alpha is 150, C is 1.44, so it's 1.44, and then gamma was 2.5 degrees, so that's the second solution. Okay, now what happened on that is, it's all about the height of the triangle, really, when you look at this kind of case. This time, if you were looking at this triangle that I just drew for the second solution, kind of what you ended up with, one of the reasons why you had two solutions is the height of your triangle, in this case, is this line segment right there. That's H. So what you could do is you could just say the sine of 27.5, this angle, is equal to opposite over hypotenuse. And then you could solve that, and I'm just going to show you on the calculator what you would get. So if you did the 16.51 right there and multiplied that by the sine of 27.5, you're going to get that the height of this triangle is about 7.6. So if you compare that to A and B, okay, in this problem again, A was given as, side A was given as 16.51, side B was given as 15.25, so you're going to notice that H is in the middle of those two numbers. So if you look at this table that I have up here, the two solution case generally comes from H being smaller than A and B. Okay? So it's not in the middle of the two, it's smaller than the two. I said that wrong. So if you look at this situation, it matches up like this. H, which is 7.6, is less than A, which is 16.51, and it's also at the same time, it's less than 15.25. Okay? So that's what happens, and that's why you get the two solution case on that then. Okay? So that table, you don't really have to know that. It's kind of nice to think through these things a little bit here. But that's why you got the two solution case, is things ordered the way they were expected to in that then. Okay, so let's go on and kind of finish this up now with a couple of application problems. So in the thing that I want to stress about the law of sines, the ambiguous case, is you just work the problem out the normal way. And what'll happen, just kind of as a summary of law of sines, when you have the ask case, is if you end up with a statement like this, you always end up finding an angle. So if you ended up with something like this, where that was outside of the domain, then that's going to be the no solution case. And then you'll end up, if you ended up with something like the sine of alpha equals something like 0.4, for instance. Let me show you what would happen in that case. If you took your calculator and did inverse sine of 0.4, you actually get two possible angles. So you might get two angles, and in that case, you might get two triangles. You don't have to, though. So kind of what would happen on this is this would be a quadrant 1 angle, but then if you did 180 minus the 23.6, you would get another possible angle. So you could based on this step. This step will either be no solution or it might generate one or two solutions. So the math leads you in the right direction. That's what I want to emphasize on that. Okay, so let's solve this problem, just these last two. All right, so this says that you have some sort of a river. So let's just draw like a picture of our river. Okay, got that. And so it says you're going to find the distance across a river. So that's implying to me that you have a side A, or a point A and a point B, and you're trying to find that distance that I'll call D across the river. Okay, so what it says is a distance BC is laid off on one side of the river. Okay, so that's going to have to be here, and it doesn't necessarily have to be at a right angle. I mean, that might be some other angle like that. So that's on the same side of the river. And that distance is 1,180 meters. Okay, so that means that we can form an oblique triangle out of this, like that. And then the other piece of information that it gave was that angle beta was 110.4 degrees, and it also gave angle gamma, which is the same as C. That's given as 12.1 degrees. Okay, so if you want to use alpha, beta, and gamma or ABC, it doesn't make any difference. Okay, so let's see what we got on this now. So law of sines, we would have to match this over the angle, and then we'd have to match the other side we know over this angle. So you have to start by finding angle A, which is very easy to do. So we know that angle A is just 180 degrees minus the sum of the two angles that you're given in this particular problem. So I'm just going to take the calculator and crunch that out. Then we'll be able to use law of sine. So let's do 180 minus parentheses 110.4 plus 12.1, and that'll give 57.5. Okay, so I'm going to add this in as something we know. That's now 57.5 degrees. All right, so now what we should have to do is just do the law of sines proportion. Okay, our job is to find D, so we're going to do match D with its opposite side. Then we're going to match this side with its opposite angle. So we have 4 things we need, 3 of the 4 being known. All right, so let's set that up. So we're going to say D over the sine of the opposite angle, 12.1 degrees, is equal to the side, 1,180 meters, over the sine of the opposite side. And then we can solve this proportion and use our calculator, then we should have a valid answer. So I'm going to multiply both sides by sine of 12.10 degrees. Okay, like that. And then we'll go to the calculator to finish up the problem. So that distance is going to be 1180 times the sine of 12.10 degrees all over the sine of 57.5 degrees. And then we can round that off maybe to a decimal or something. Okay, so let's do that. So we got 1180 multiplied by sine of 12.10 degrees, and then divide by the sine of 57.5, and that will give an answer of about 293.3 meters should be what that distance is. So what we just found on here is this distance across the river is 293.3 meters. Okay, so that is the answer to the problem. So see, in surveying, you don't have to have right triangles. You can have oblique triangles. And many times that's practical because a lot of times it's impossible to come up with a right triangle because of different aspects of what might be out in the field. Okay, so let's do one more. This last problem right here, I think I had gone through how to do this in a little more complicated way with right triangles a little bit earlier in the semester. So this problem says you have a guy wire to a tower is making a 75-degree angle with level ground. So let's just kind of draw a picture of the tower. Now the tower does not necessarily have to be at a right angle maybe. So we're not ready to assume whether or not it's a right angle yet. And it says the guy wire is 75, makes a 75 degree with level ground. So I'm just going to assume that the guy wire is on the top. So I'm going to just represent something kind of like this. This is going to be my guy wire, like that to the tower. And that's going to be making a 75 degree angle with level ground. So that's going to imply that you have that situation. Whether if that's a right angle, we don't really know, and it may not matter depending on what we're given. Okay, so then what it says, at a point 40 feet further back from the tower than the wire, the angle of elevation to the top of the pole is now going to be 33 degrees. So what's going to happen here now is this is really saying that you're going out a little further. So you're going out 40 feet further, and when you remeasure that angle of elevation, it's, of course, is going to get smaller. So that angle of elevation now is going to be 33 degrees. Okay, which should be logical, so we have that. Now what it's going to say is we're going to find the wire length. So the wire length is going to be this distance right there of that part of the triangle is going to be that. Okay, so we got to find that. So this is going to be, we're going to see if we can figure out using law of sines on this. So we got an oblique triangle here. We have an angle. There's several things we can figure out on this. We could actually figure this angle out there, and then that would lead us to figuring that angle out there. That's an oblique triangle if you look at that part right here. So the way I'm going to suggest that we solve this is we're really going to look at this oblique triangle. I'm just going to kind of highlight in the oblique triangle that I'm talking about, and we should have enough information on that to utilize law of sines on that. Okay, so what I'm going to do is a couple of very simple calculations. Okay, if I want to find this angle right here, that's 180 minus 75 degrees. So that's going to be a 105 degree angle. And then this angle here is just going to be 180 minus the 33 plus 105. So there's enough information on this problem to find all of the angles of that oblique triangle. So I'm going to do that next and do 180 minus the 105 plus 33, and that'll give that little leftover angle, which is 42 degrees. Okay, so now I should have enough to set up a valid law of sines proportion to finish up this problem then, so that's what I'm going to go ahead and do. Let's see if we got enough information. Okay, so we have a side that we're finding, and then we do have, that's the angle opposite. Okay, we do have a side, and we have an angle opposite. So when we set this up, we're going to say x over the sine of 33 degrees is equal to 40 over the sine of 42 degrees. Okay, all I got to do is solve this. So I'm going to multiply both sides by the sine of 33 degrees. Then I'll go to my calculator, so I have x is equal to 40 sine of 33 degrees divided by sine of 42 degrees. Then I'll have an approximate answer to that problem. Okay, so let's do that. So we got 40 sine of 33 degrees divided by sine 42. And that'll give a height of about 32.6. And that is in feet. So that would be what that solution is. So we have found that part right there to be this. Okay. Now see, notice on this one, it didn't matter what that angle was. You didn't have to assume it was a 90 degree angle because you had enough information on that using law of sines to solve it that way. Okay, so that will be the end of this. And I'll tell you the thing on this section. Law of sines usually is a very easy thing for students to learn. The ambiguous case is the most challenging part of that. The mathematics leads its way through that problem. It's very logical. So if you see an ambiguous case, just solve it like you would any other case. And either you're going to find you have a 1, 2, or 3, or I'm sorry, 0, 1, or 2 solutions. All right, so that will be the end of it. So I hope this went well for you. Have a good day, and hope you do well with your assignment on Law of Sines.